Hi, good evening. Please give me thumbs if I am audible. Good evening. Please give me thumbs if I am audible. Am I audible? Am I audible? Yes. Okay. So, good evening. Welcome to GoScore Learning. We are the fastest growing edtech in GCC, and our aim is to provide quality education for all. So, myself, Rahul Praj from Physics Department of GoScore Learning. So, here I am today. Here I am to take, like, as you can see the thumbnail, or as you can see in the board. So today I'm going to discuss the board exam question paper for the year 2024 for grade 10 physics. Okay, so as you know, like, there are different sets of question paper. Almost 5 sets of question papers are available. So today I'm going to discuss one among the sets. Okay, so which is asked in in the GCC region last year. Okay, so this is the question paper code that we are going to discuss, set 1 out of the 5th one. There are 5 set. Out of the 5th set we are discussing, in A, B, C, 3 different set will be there. So the first set of 5th one, that's what I am going to discuss. So this is the question paper code 31 bar 5 bar 1. So that doesn't matter at all. Okay, so as you someone have noticed, my sound have some slight difference for today. Like, my thought is not like that much good. Like, some thought pain is over there. Anyway, I am here to as I have promised, like, we'll be discussing the not sample question paper, previous year question paper in our classes. So that's why I'm here today. Okay, so I hope I'll be awaiting this kind of cooperation from your end also. Okay, so I know all of you have finished the revision for first round, second round, maybe third round also finished. Now you are in behind, running behind to finish the most of the previous year question papers, sample paper, etc. Right? Okay, so today we will be discussing the question that is asked in last year board exam for especially Kuwait students or the GC students. You might have, like, if you are in 11 now, because your seniors, the grade 11 students. So I am going to discuss your question paper, like, that you have attempted. Okay, so today we can directly move to it. Okay, so MCQ, out of MCQ, the 11th question, first question for physics is come from the 11th one. 11th question is, how will the image formed by a convex lens be affected if the upper half of the lens is wrapped with a black paper? Okay, so when I have discussed this question in our grade 10 student, with our grade 10 students in our offline class, like, I have mentioned with them, like, actually they are embracing, like, this question. You can see the same question in the question bank of, or the previous year questions of grade 12. Okay, so same question you can expect, like, you can see in grade 12, in the chapter ray optics. Okay, and it's been asked, like, in different school exam, like the exam conducted by school for grade 12, the same question has been asked. Okay, so let us see, like, let us, like, get into the question. Okay, so this is a creating or evaluating type of question. This is not about understanding, it's not about remembering, it's not about applying. It is creating and evaluating type of question, like the level 3 type of question. Okay, so here what is given? Convex lens. Okay, the color is not seems to be good. Okay, convex lens it is. Okay, so for a convex lens, okay, so we can draw a simple diagram for which image is forming over there. Okay, so, like, there is an object. Okay, let us take it like image is forming over here. Okay, so an inverted image is forming over there. Okay, so what is happening here? What is happening here? The upper half of the lens is wrapped with a black paper. So the upper half is wrapped with a black paper. Okay, so if I am drawing with a black paper, you can, like, see it as it is a blackboard. So I'll do one thing. I'll be, yeah. So this half, upper half. is completely covered. So as it is completely covered with a black one, black paper, you can see that from the upper half, light won't be refracted. Light won't be refracted. So now, could you please tell me what is the answer for this question now? So whether the image will be formed, what are the options? The size of the image form will be one half of the size of the image due to complete lens. So when the complete lens is there, there will be an image formed, and the size of the image will be halved because of half of the mirror is covered. Are you expecting that one as the answer for this particular question? Are you expecting? Okay, no way, no way. Okay, image of the upper half of the object will not be formed. Upper half of the object, like, so here only the object is completely placed upper half. Okay, if the image object you have placed is like this, whether this upper part means like this much of portion of the image will not be formed like that. Is it like that? Is it like that? Okay, the brightness of the image will be reduced, the lower half of the inverted image will not be formed. Okay, so what is the right answer for this question? Actually, the right answer is option C. The brightness of the image will reduce. That is the answer for this question. Okay, how come, sir? How come this like become the answer? Okay, we can explain it simply. Okay, so here whenever the object is here, incident rays are coming. What I have marked is only the incident rays which is falling on the upper half of the mirror. Now it is covered with a black paper. Okay, so actually there are infinite number of rays which is coming from the object, and it can be falling to the lower half. It can be falling to the lower half. So from the bottom part, lower half of the mirror, sorry, not mirror, lens, from the lower half of the lens, the light will be refracted. Only the upper half is covered with the black paper, but the lower half is still there, and it will be able to refract the light. It will be able to refract the light. So what happened ultimately? Upper half light will not be refracted because it's covered with the black paper, and lower half will be refracted. So actually we can take like half of the intensity of the light is falling on upper half, and half of the intensity of light which is coming from the object falling on lower half. So the upper half light will not be refracted anymore because it's covered with the black paper. Okay, so what will happen now? The lower half will be refracted light, and the image will be formed. So not all the light which is falling over there is not refracted, only some part. Let us take like half of the part of the light is refracted. So ultimately image will be formed as such, but the brightness or intensity or brightness of the image form will be reduced because not all the light which is coming from object is not refracted. Okay, so that is the simplest explanation for this question. So like we can directly hit for the option C. You can directly hit option C as the answer. Okay, is it clear, my dears? Is it clear? There is no like, pardon me. Okay, so there is no like high-end concept over that. Just you have applied the concept of image formation in a lens. Okay, so the concept can be applied over here. You'll be getting the answer. That's it. Clear? Easy one. Easy one. Okay. Could you follow? Could you follow? Can I move to the next question? Okay, look at the next question, which is coming from yeah, rainbow. Rainbow formation. Okay, so I like used to tell my students, you can expect a question from the human, especially from the human eye chapter. You can expect a question from a prism for sure, or related to rainbow. So in every question paper you can see that there will be a question related to prism, or there will be a question related to rainbow. That's for sure. Like last time, the question which is coming in physics for rainbow, it was like an MCQ. Even though like a MCQ, if it is as an MCQ, the entire concept of rainbow formation that you have learned is applied over here. So what is the question? The phenomena of light involved in the formation of rainbow are, what are the phenomenon? Okay, like by reading the option, it seems to be a confusing kind of question. Okay, so confusing option, it is refraction, reflection, dispersion. Refraction, dispersion, and internal reflection. Reflection, dispersion, and internal reflection. Refraction, dispersion, scattering, and total internal reflection. Okay, scattering. Scattering is not at all happening over there. Wrong option, option D. Okay, in rainbow, what is scattering which is happening? There is no scattering for in the formation during the formation of rainbow. Okay, so option D completely ignored. Okay, refraction, refraction, dispersion. So you can see that dispersion is there in the every option. Okay, so dispersion is there for sure. Dispersion. What is dispersion? The phenomenon of splitting of white light or composite light into its constituent colors is dispersion, right? Okay, dispersion is there, then only rainbow can be observed. Okay, so internal reflection also. Internal reflection is there. Internal reflection is not included in this option A. So option B or option C is the answer. Okay, so my kids, is there anyone who can answer this question for easily? Okay, is there anyone who can answer the question? Please, is there anyone who can answer the question? Refraction, dispersion, and internal reflection. Reflection, dispersion, and reflection. Okay, you know that during the formation of a rainbow, what is happening? What is happening? A white light is coming. White light is coming, and it will be refracted along with a dispersion. This refracted along with the dispersion. Then what is happening? This is how rainbow is forming here, right? So here, this is the pictorial representation of a formation of rainbow. Pictorial representation of formation of rainbow. So here, what is the phenomenon happening here? What is the phenomenon happening there? Okay, actually I find I have made a mistake. Okay, so here, okay, there should be bending that I forgot. Okay, now it's okay. So there should be a bending, refraction should be there now. Okay, fine. Now the diagram is here. Okay, so what is the phenomenon occurring over here? That is refraction and dispersion. The color have been splitted along with refraction is over there. Bending of light is also there. Okay, so refraction, dispersion is over there. And what is the phenomenon over there? Internal reflection. Internal reflection, which is happening here. Internal reflection. In third stage, what is happening? Again, refraction. Okay, so refraction is there, dispersion is there, internal reflection. Okay, so actually in like next time this year you can expect, give with the help of suitable diagram or with the help of a diagram, explain the formation of rainbow. So this is the diagram with neatness you have to draw, then explain the different phenomena involved: refraction, dispersion, internal reflection, and again refraction. Okay, so option refraction, dispersion, internal reflection, option B is the right answer. Okay, like always, yeah, option B is the right answer. Easy species, lemon species. Okay, okay, very easy one. Okay, so it's a like direct question from the topic, rainbow formation. Those who are okay with the concept can easily answer the question. It's not a Herculean task. Okay, fine. Okay, now let's move to the next MCQ, which is asked from, yeah, 13, 11th one, 12th one, now 13th one. Okay, so 1 3. The color of light which the refractive index of glass is minimum is. Okay, so frankly speaking, this question can be considered as out of syllabus question for our kids. Like in by simply looking at the textbook, like we can't consolidate or we can't find the answer, we can conclude the answer. Okay, so like application, creating, evaluation, everything is required over here. Okay, is the question is readable? Okay, so is there anyone who can answer this question? Please let me know. Is there anyone who can answer the question? No one. Okay, so the color of light for which the refractive index of glass is minimum is, answer is red. Why? Because refractive index is inversely proportional to wavelength. Okay, refractive index is inversely proportional to wavelength. Refractive index is inversely proportional to wavelength. This is a concept that we get. Okay, refractive index is inversely proportional to wavelength. Yeah, refractive index is inversely proportional to wavelength. Okay, so wavelength is high for red. So higher the wavelength, lower the refractive index in glass. Okay, so this is a concept which is secured over there, which is a grade 12 topic or grade 12 equation. Okay, anyway, it's been asked. Okay, last time. Okay, so as red have more wavelength, it have least refractive index. Okay, so which have maximum refractive index? Maximum refractive index for violet, because violet have, sorry, yeah, violet have minimum wavelength. minimum wavelength. Maximum wavelength is for red, so it is having minimum refractive index. Or we can also take it like when white light is splitting, dispersed okay from glass prism, you can see that the less deviation is for red and maximum deviation is for violet. So refractive index can be taken as like more the deviation for the light, more will be the refractive index for it. Okay, more the deviation for light, more the refractive index for it. Okay, so here more deviation is for violet. Okay, it's not a violet color. Okay, let us take it as violet color for now. Okay, more is for that one and less deviation is for red. So lesser the deviation, lesser the refractive index. You can also connect in that way. Okay, you find it? Okay, so easy. Could you follow? Did you get the concept what I am saying about? More the refractive index, more the deviation. So here more deviation is for violet. So violet has more refractive index. Less the deviation for red, red has least refractive index. Or the direct equation is refractive index is inversely proportional to wavelength. Wavelength means lambda, lambda. Okay, fine, fine. Okay, now next one, again the fourth one, the current carrying device which produces a magnetic field similar to that of a bar magnet is. Okay, so easy, a direct question. Okay, no need to think about what is the answer. Solenoid is the answer. Okay, so you know that what is a pattern of magnetic field produced by a straight conductor. Okay, uh, current carrying straight conductor will be producing magnetic field in the form of circular concentric circular loop. Okay, magnetic field in the form concentric circular loop, and the axis of the loop will be acting as, sorry, axis of the wire will be acting as the center of the loop. Okay, then circular loop, what is the shape of the magnetic field produced by a circular loop? If this is a circular loop, magnetic field produced by it is like like this is the magnetic field produced by a circular loop. Okay, so a pictorial representation that I have given. Okay, then what is the magnetic field produced by a solenoid? It is similar to that of a bar magnet. That's, you know, right? What is a magnetic field produced by a bar magnet? This is a bar magnet. Magnetic field produced by it is like this. So similar, inside the magnet, magnetic field lines are uniform like that. So this is structure of the magnetic field produced by a bar magnet, right? Same kind of magnetic field is produced by current carrying solenoid, and we have discussed that a current carrying solenoid will act as a bar magnet. Okay, will be showing similar properties as that of a bar magnet. Okay, then okay, so here this question is from last chapter, magnetic properties of electric current. Okay, so like seems to be a lengthy question, but answer is very simple. Okay, so uniform magnetic field exists in the plane of a paper as shown in the figure, in the diagram. In this field, an electron and a positron. Yeah, you might have confusion. Sir, what is positron? What is positron? What is positron? Any idea? Positron is the antiparticle of electron. Like it have same mass, same charge, opposite charge as it of an electron. Okay, so positron like same mass of electron but opposite charge. So it is given over there. Electron having negative charge, positron having positive charge. Already is given in the question. So if you don't know about positron, like take it like there is a positive charge which is mentioned, right? So it has positive charge. Let us take it like a proton like particle having positive charge. Okay, so n is as shown in the figure. So every time, like when we are discussing this topic, I used to say that direction of current is taken as same in the direction of flow of positive charges, and direction of current is taken as opposite in the direction of flow of negative charges. Electron being a negative charge, if electrons are oh, if electrons are flowing downward, its current is upwards. Current is upward. If proton is moving upward, current is also upward. So ultimately, because of flow of these charges, electron and a positron, the current upwards. Current is upward. What do you need to find? The force direction. The force direction we need to find. So what's the name of the rule? What we need to use here? What we need to use here to find the direction of force? So you are learning right hand thumb rule. Fleming's left hand rule is over in this chapter, and out of which right hand thumb rule is for finding the direction of magnetic field by a straight current carrying wire, and Fleming's left hand rule is therefore to find direction of force on a current carrying wire on a magnetic field, placed in a magnetic field. Okay, so could you please state Fleming's left hand rule? Okay, so keep it that in the sentence in your mind, the definition in your mind. Okay, so stretch thumb, pointing finger and middle finger, index finger and middle finger of your left hand, specifically like need to specify of your left hand. Okay, stretch thumb, index finger and middle finger of your left hand in such a way that it's in mutually perpendicular direction, such that if father, mother, child, see current. So if the middle finger shows the direction of current, and mother, father, mother, M, magnetic field, index finger shows the direction of magnetic field, then thumb will points in the direction of force on the current carrying wire. That is the Fleming's left hand rule. Okay, let us take it like direction of current upward. For both the particle, current is upward. So no need to consider separately. Okay, current upward, current is upward, magnetic field in this direction, uniform magnetic field in this direction. So magnetic field in this direction. And what is the direction of my thumb? What is the direction of my thumb? Thumb points. My thumb is pointing into the plane. So the force will be points into the plane. Okay, for electron, it is pointing into the plane. For positron, as the current direction of current is same, both the particle will be experiencing force into the plane. Okay, into the page. Okay, so both pointing into the plane of the paper, both pointing out of the plane of the paper, pointing into the plane of the paper and out of the plane of the paper respectively. Okay, so here these two options are incorrect because both are having same force which is into the plane. Okay, so option A is the correct answer, into the plane of the paper, into the plane of the paper. Okay, could you follow? Is it necessary to one second? Okay, fine. Option A is the right answer. Option A is the right answer. Okay. Then this one seems to be assertion reason. Yeah, assertion reason question. You can have one assertion reason from physics. Okay. So electron move from lower potential to higher potential in a conductor. Yeah. So when you have a conductor, okay, lower potential will be like negative, higher potential positive, or +5 +7. Even though both the +5 volt and +7 volt, even though both the terminals are positive potential, one is having higher potential and the other is having lower potential. This is higher potential and this is lower potential. Okay, so for our easiness we can take it like positive and negative. Okay, so what is the direction of current flow? What is the direction of current flow? From positive to negative. Current is flowing from positive to negative. Okay, what is the question? Electrons are moving from, if current is from positive to negative, you know that direction of current is opposite to the direction of flow of electron. If current is from positive to negative, electron should flow from negative to positive, lower to higher. From lower potential, again color, lower potential to higher potential. It is flowing from lower to higher. So assertion correct. Whether the assertion is correct? Yes, assertion is correct here. So assertion correct. Okay, then check about the reason. Check about the reason, whether the reason is correct or wrong. Let us check it. Okay, so a dry cell maintain electric potential difference across ends of a conductor. So what is dry cell? Is it like beef dry fry like BDF? Okay, dry cell. Okay, what is a dry cell? A cell which is very dry. Yeah, like not like that. Dry cell means the cell that you are using, the remote in the remotes, the cell that you are using in like the watches, cells that you are using in clock, those kind of cells, those kind of cells are termed as dry cell. Okay, why? Because the electrolyte that you are using inside the cell is like comparatively dry when you are comparing to the inverter batteries or the batteries that you are using in vehicles. When you are comparing to that, the electrolyte that you are using over here is the form of a paste, which is very like dry compared to the liquid electrolyte that we are using in other cells. Okay, so here this kind of cells are called dry cell. So dry cell means the you can think about the battery, sorry, not the battery, the cell that you are using in remote, so cell that you are using in clock and all. Okay, so dry cell maintains electric potential difference across ends of a conductor. Correct only. So electric cell or the cell is the device. A cell is the device which is used to, or a battery is the device which is used to maintain an electric potential between the ends of the conductor. Correct only. Solution is also correct. Now the next question, whether reason explains assertion. Whether the reason explains assertion. Whether reason explains association. A dry cell maintain electric potential across the ends of the conductor. So here electron move from lower potential to higher potential. So, okay, so could you please answer whether the reason is explaining the association? So is there any, are they connected? We can make it like connected, but whether it is explaining, no, it is not explaining. So what is the answer for this question? Both assertion correct, reason correct, but reason does not explain association. Okay, reason does not explain assertion. That's it. Okay, okay, fine. Okay, let us move to the B part. Section B. Okay, the heat produced at a point due to the, and second, the heat produced at a point due to the concentration of sunlight by a convex lens burns a paper. You might have seen like using the, what is it, like magnifying glass that you have. You might have like experimented with burning a paper in sunlight using it. How it is happening? How it is happening? Explain what happens. Okay, so as convex lens is a converging lens. As convex lens is a converging lens, what it will do? So it will be when the parallel rays are coming, it will be converges all the light rays into the into a particular point. Okay, so the sunlight will be concentrated at a particular point so that it will burn the paper. That is what is happening there. So this is what is happening. So in the Markov scheme also, like we can simply explain this. Question number 25. Yes. Okay. So the sunlight is converged at a point by the convex lens. As convex lens is a converged lens, the sunlight will be converged to a particular point. That's why the paper burns. Okay, the paper got burns because of that. Okay, then name the term in the context of lens use given to the point at which the paper start burning. In the paper, you can see a bright spot when you are like converging all the light rays over there. So that bright spot is called incident rays are coming parallel from a sunlight. So where it will be converged? Where this bright spot in the context of lens? Focal length. Or sorry, principal focus. So his name is principal focus. Principal focus, principal focus, or simply focus. Okay, principal focus it is. In the context of lens, it is principal focus. What does the bright spot formed due to the paper represent? What is that bright spot? Is there anyone who can answer the question? What was that bright spot? Actually, it is the image of the sun. The bright spot is the image of the sun. Very diminished, highly diminished real image of the sun. Highly diminished. What is the answer for this question? Highly diminished, highly diminished, highly diminished real image of sun. Highly diminished real images of, that's it. Okay, does it find easy? Does it find easy? Yes, that's it. Okay, next question. An electric source can supply a charge of 500 coulomb. If the current drawn by the device is 25 milliampere, find the time in which the electric source will be discharged completely. Okay, so every year you will be suffering, you will be facing, not every year you are not going to face, right? Actually, like as we teachers, we can represent every year, like in 10th, different types of numerical will be asked from electricity, not only for electricity, from every chapter you can ask for like a new kind of question, new pattern, like a different question. So this is also question like that. Okay, so here for this kind of numerical, what you need to do, especially I will say like any numerical that you can get from electricity chapter, what you need to do is you should write the given details. What is given? A source of can supply charge of 500 coulomb, charge Q equal to 500 coulomb. The current drawn by the device is 25 milliampere. So I 25 milliampere. 25 milliampere means milli means 10 to the power minus 3. 10 to the power minus 3 into 10 to the power minus 3 ampere. Okay. So find the time. We need to find the time. Now it's just a matter of time. So yeah, now it's just a matter of time for you. What is the relation connecting them? What is the relation connecting Q, I and T? My dears, what is the relation connecting them? Q, I and T. What is the relation? What is the relation for it? You know that I is equal to Q by T. So T is equal to Q by I. So what an easy question. How can you get a question which is simpler than this one from electricity numerical? Very easy one. Very easy one. Okay. So you substitute the values over there. Substitute the values over there. Okay. So Q means 500. 500 divided by 25 into 10 to the power minus 3. Come to numerator 10 to the power 3. So 50, 25 2 times. So 20 into 10 to the power 3. 20 into 10 to the power 3 second. 20 into 10 to the power 3 second. We can take it like 20 after 3 zeros. This much of 20,000 seconds. Easy peasy. Okay, so 20,000 seconds it is. Okay, so clear? Clear, very easy numerical, right? Very easy numerical. Very easy numerical. Okay, is it not visible for you? Yeah, very easy numerical. That's it. Okay, very easy one. Within 2 steps, you have got the answer. That's it. Okay, clear? Clear? Yes. Okay, so yeah, next one. 31st, study the diagram. So we are studying, sir. Okay, studying the diagram given below and answer the question that follow. Okay, so name the defect of vision depicted in the diagram, stating the part of the eye responsible for this condition. Okay, so as image is formed far from the islands, it is farsightedness or hypermetropia. 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 So no need to by heart anything. If the image formed is far away from the lens, farsightedness or hypermetropia or long-sightedness. That's it. Okay. So and also along with that, there is a question asked stating the part of the eye responsible for this condition. So what is the part of the, no, it's not the cause of this one. Cause of this defect is asked separately. Here the part of the eyelids, sorry, part of the eye which is responsible for this one, ciliary muscle. Ciliary muscle, you can answer like ciliary muscles and eye lens. Ciliary muscles and eye lens are the part. Ciliary muscles and eye lens are the part which is responsible for this defect. Okay, state the cause of this defect. What is the cause of this defect? We can have two causes. Okay, one is like very easy. Focal length of eye lens. What happened? What is increased or decreased? Focal length is increased. That is why it is forming over here, right? So focal length of eye lens increased. Focal length of eye lens increased. Okay, now another reason. What about the size of the eyeball? Size of the eyeball. If it is here, eyeball is having larger size, it can accommodate the image formed on the retina itself. As it is reduced, it is forming beyond the retina, behind the retina. So eyeball size reduced. Eyeball size reduced. That's it. eyeball size reduced. Very easy, very easy. Okay, that name the type of the lens used to correct this defect and the state the role in this case. Okay, so remember, I have seen in like when the model exam that you are conducting, pre-board that you are conducting, I have seen most of the questions are will be answered. Name the type of the lens used. There will be write the name of the lens and like direct question, but they forgot to answer the second question along with this. Okay, so here also there is another question like stating the part of the lens responsible for this. So if you are simply writing it is hypermetropia, as it is 3-mark question, 1 mark here, 1 mark here, 1 mark here. Okay, if you are simply writing hypermetropia only, you are going to get half mark only for this. If you are writing stating the part of the lens responsible for this, then only you will be getting half plus half. Okay, state 2 causes of this defect. So for one cause you will be getting half plus half, then only you will be getting 1 mark. Okay, only you will be getting 1 mark. Okay, name the type of the lens used. For writing the type of the lens, as it is convex lens which is we used, because hypermetropia is corrected by using convex lens. Okay, so convex lens is to be used by writing the type of the lens, or convex lens or converging lens. Okay, so by writing the type of the lens, you will be getting half mark. And state its role in this case. State, you need to state the role. What is the role of that lens over here to correct it? Actually, the image formed is far away from the retina. Okay, so we need to have more convergence, or the focal length is increased, right? So we need to reduce the focal length. So reduction of focal length can be done by reducing the increasing the convergence. Okay, more the convergence, less the focal length. Okay, so we need to reduce the focal length by converging it. So that convergence can be given by convex lens. So in this context, you can answer they provide, convex lens provide the additional focusing power required for forming the image on the retina. The additional convergence to form the image on the retina will be given by the convex lens, so the converging lens that you are using. So that should be the answer for state its role in this case. The additional convergence will be provided by the convex lens that you are using. That's why it can be used for rectify hypermetropia. Clear, my dears? Is it clear, my dears? Okay. Okay, then there was an or question for it. Okay, for the entire question there is an or. Okay, not for the last third question in that. For the entire question there is an or question which is like 3 mark, as for 3 mark. Okay, as I stated, yeah, dispersion of white light. Okay, so here is the question which is related to prism. Here the question which is as related to prism. So prism, prism, prism. Okay, let us take a look from here. First triangle. Yeah, prism. What is dispersion of white light? What is the dispersion of white light? The phenomenon of splitting of white light into its constituent colors when it is passing through a prism is called dispersion. Okay, direct definition which is asked. Okay, pretty easy. State the cause. What is the cause of dispersion? The cause of dispersion we can state in different way. So one of the reason like that we can write, the different colors are having different angle of deviation with respect to incident ray. Okay, or similarly you can write different colors have different angle of deviation, different colors have different velocity in the glass prism, different colors have different wavelength. Any three option, any out of these three you can write any one, you will be getting the mark. Okay, so better to write the thing which is given in a textbook, which is as the different colors have different angle of deviation, that's why dispersion occur. That's it. Okay, so draw the diagram to show the dispersion of beam of highlight by passing through the prism. So for this question, for writing the definition, you will be getting 1 mark. For stating the cause, you will be getting 1 mark, and drawing the diagram, you will be getting 1 mark. Okay, that's how the distribution. Okay, so white light is coming. White light hit us here. When white light is sitting over there, you can see it refracted. Okay, indigo, violet indigo, indigo. Okay. Okay, then you should mark. white light, the arrow mark for it, give the arrow mark, then red one and violet. Okay, you should mark the top one and the bottom one. You can mark. You'll be getting mark as you are supposed to draw the black and white diagram using pencil. You can mark like better to mark red, violet like that, or it's better to add all the in between colors also you can add. Okay, orange, then yellow. Don't worry about it. Like you can mark with a pencil. That's it. Yellow, violet, indigo, blue, red. So only mark indigo, indigo, blue, green. Also the green like that. So you can mark violet, indigo, blue, green, yellow, orange, red. That's it. Okay, so you can mark you can mark different 7 lanes, and you can mark like red, orange, yellow, blue, sorry, green, blue, uh, indigo, violet like that from the top. Red, orange, yellow, green, blue, indigo, violet. That's it. Okay, fine. Yes. Now, okay, what happens? What happens when a bundle of wires of soft air is placed inside the coil of a solenoid carrying a steady current? Name the device obtained. What way is it called? So, okay. So it is a 5 marker. So sorry. It's again a 3 marker. Okay, 3 marker question. Okay. So what happened when soft iron core inserted into the solenoid? It became a strong electromagnet, or the soft iron become magnetized. The soft iron become magnetized. Magnetized. 1 second. Pardon me. It become magnetized. The soft iron become magnetized. Okay. So what happened when a bundle of wires of soft iron is placed inside a current carrying solenoid? It become magnetized. Okay. Name the device obtained. What is the device obtained called? Electromagnet. Electromagnet. The device is called electromagnet. It's a direct question, right? It's an electromagnet. It's a direct question. Like, why is it called so? Why electromagnet is called electromagnet? It's not a permanent magnet. Solenoid, if there is no current flowing through it, it will not produce magnetic field. Whenever a current is flowing through the solenoid, then only it become a magnet. So that's why it's termed as electromagnet. So we can emphasize the solenoid become a magnet only when electric current is passing through it. So it is a magnet. It is a magnet only when electric current is passing through it. That's the reason. So it is called electromagnet because it acts as a magnet only when electric current is passing through it. That's it. Okay. So if you, unless and until if you are not writing the reason, you are not getting going to get the full mark, 3 mark for this question. Okay, definitely your marks will be lost. Okay, I'll check the like mark distribution. For writing, it is magnetized, it is half mark. Electromagnet half mark, and for the reason half mark, 1.5 mark. Okay, that's how the distribution. Then, so unless and until if you are not writing this one, you are not writing this one, you are not going to get the mark. You are not going to get the mark. Okay. Okay, then draw the magnetic field lines inside a current carrying solenoid. What does it? What does this pattern of magnetic field lines indicate? Okay, so could you please show the 1 second? Okay, shape of the magnetic field by a current carrying solenoid is similar to a set of a bar magnet, right? Okay, so inside the magnet. So here the question: draw the magnetic field lines inside the current carrying conductor, current carrying solenoid. Inside, they have only talked about the inside field. Okay, so inside, what is the pattern? You know that magnetic field inside a current carrying solenoid is uniform field. Okay, what are the peculiarities of a uniform magnetic field? Uniform magnetic field are parallel, parallel, Uniform magnetic field can be represented as parallel, okay, parallel, equidistant, whether it is equidistant, yeah, equidistant, parallel, equidistant, same direction, three condition. A magnetic field is uniform when they are parallel to each other, when they are equidistant, and when they are in the same direction. So here they are in the same direction, parallel, equidistant. Okay, so this is the magnetic field inside it. Okay, so question only asked for draw the pattern, draw the magnetic field lines inside the current carrying solenoid. By simply drawing this, you will be getting marks, no doubt. Okay, and if you have any doubt, like you can also do the solenoid of the, that's it. Okay, by simply writing this one, you will be getting mark, and if you are drawing along with this, also you will be getting mark. But here you can attach a cell to it so that it become current carrying solenoid. That's it. Okay, got it. So by simply drawing this, you'll be getting mark, and along with this also you'll be getting mark. That's it. Okay, okay, easy, easy. Okay, now I think second last question we can wind up like in a couple of minutes. Okay, okay. So comparatively, what you are like expecting? So what is your uh, opinion about the so far about the question that is asked last time? Is very easy. Only MCQs have trouble to you. Other than that, all the B part question, C part question are very easy, right? Now let's move to the 5 marker. Yeah, 5 marker physics topic. Okay, physics subject. Okay, the potential difference across two ends of a circuit compound decreases to 1/3 of its initial value, while its resistance remains constant. What change will be observed in the current following through it? Name and state the law which help us to answer this equation. Answer this question. Okay, so you read the question for 1 or 2 times, then only you can like pause the video and read the question for 1 or 2 times. For me as a teacher, like as I have seen this question before, like I have got the concept. Okay, for you as a lengthy sentence, read it for 2 or 3 or 4 times. That's the things which is given in this question. Okay, so what is happening here? Potential difference across two ends of the circuit compound decreases to 1/3 while resistance remains constant. What is the change on current? That is a question. You know that. Okay. What is the change on current? What is the change on current? That is the question. Okay. You know that I is equal to V by R. Okay. So here what is happening? V change it to V by. So it should be capital V, right? Yeah. Potential difference is changed to V by 3, or our new V dash is equal to V by 3. R is not at all changing. So R dash is R only. Okay, we need to find the new current. New current I dash is equal to V dash by R. V dash by R. What is V dash? V by 3 divided by R. This is equal to 1 by 3 V into R. 1 by 3 V into, what is V by R? 1 by 3 V into, not 1 by 3 V into R. 1 by 3 into V by R. What is V by R? I only. Okay, so I dash is equal to 1 by 3I, or I dash is equal to I by 3. So without changing resistance and the potential difference reduce it to 1/3, current will also reduce to 1/3 because V is proportional to I. V is proportional to I. If voltage reduced to 1/3 without changing the resistance, current will be also reduced to 1/3 as they are directly proportional. Which law is that? Ohm's law. It is Ohm's law, sir. Yeah, pretty easy. So what is the question over there? Name and state the law which is help us to answer this question. So what is the name of the law? Name of the law is, it is Ohm's law, sir. Ohm's law. Name the law, Ohm's law. State the law. At constant temperature, potential difference across the ends of the conductor is directly proportional to the current passing through it. That's it. Okay, at constant temperature, potential difference across the ends of the conductor is directly proportional to current flowing through the wire or current flowing through the conductor. Ohm's law. Ready? V proportional to I, V equal to IR. By stating the law, you can also write. After stating the law, you should write mandatory. You should write V proportional to I, Okay, right here, V equal to IR, where R is called resistance. Okay, so write the mathematical form of its the law, Ohm's law, and by writing R and R. Okay, you see, okay, this much you need, right? Okay, so actually, when we are checking with the markings for this question, what is the question number for it? Question number 36. Okay, 36. Okay, so current become one third of its value, ohm, so you can state. Then after that, you can state the potential difference across the ends of a conductor is radially proportional to the current flowing through it, provided its temperature remains constant. State the law. That's it. You can also mention about its mathematical form. That's it. Okay. Now let's move to the second part. Draw a schematic diagram of a circuit consisting of a battery of 1.5 volt cell and a 5 ohm resistor, a 10 ohm resistor, and a 15 ohm resistor, and a plug key, all connected in series. Now find, there are two questions. Okay, first of all, we can construct the circuit diagram, schematic diagram representation. Okay, so what are the components for 1.5 volt cell? So we can write. Okay, for 1.5 volt cell connected in series. Okay, so as it is 1.5 each, so there are 4 volt, sorry, 4 cells, so total volt become 6 volt. They're connected in series, so 1.5 into 4, which is 6. Okay, and a 5 ohm resistor, 10 ohm resistor. So what are the resistors? 5 ohm, then 10 ohm, then 15, then a plug key. That's it, right? Okay, a key, we can close it. Okay, so 5 ohm is there, 10 ohm is there, 15 ohm is there. Okay, so 15 ohm is there. So this is the schematic diagram. Okay, or connected in series. Now find, there are two questions. Okay, first one, the electric current passing through the circuit. Okay, so we know that I is equal to, current is equal to V by R effective. V by R effective. Okay, current is I is equal to V by R effective. What is R effective here? R effective here is equal to, as it is series combination, we can add R1 plus R2 plus R3. So it is 5 plus 10 plus 15. 5 plus 10 plus 15 it is equal to 15 plus 15, which is equal to 30 ohm. 30 ohm. Okay, they are connected in series, yeah. So connected in series, so it is 30 ohm. So this is R effective. So what is I then? I is equal to V. What is V? 6 here. 6 by 30 is equal to um, 6 is 1 by 5. 5 is a common divisible, right? So 1 by 5 is, so 6 is the common divisible. 6 one time and 30 5 times. Okay, so 1 by 5 means 0.2. So 0.2 ampere it is. 0.2 ampere. Easy, right? Easy, very easy. Okay, so 0 ampere it is. So first one, that electric current passing through the circuit is 0.2 ampere. Then second question is there. What is the second question? And potential difference across the 10 ohm resistance. Okay, so potential difference V of 10, 10 ohm resistor, V of 10, we can like call it like V of 10. So V is equal to, you know that V is equal to IR. V is equal to IR. What is the current? As it is series circuit, every component will be having same current. In a series circuit combination, all the components will be having same current. So current already you have find 0.2. What is the resistance over there? It is 10 ohm. So which is equal to 0.2 into 10, which is equal to 2 volt. Very easy. So like you are very lucky, like the grade 11 students, you are very lucky, like you have got an easy question from electricity. Okay, like it is not a complicated question, very easy direct question, right? Very easy, very easy. Fine. Could you follow? Could you follow? Yes, done. Okay, like there should be another question for this one. Yeah, there is another question. Okay, there is another question, and again 5 marker. Okay, also it is asked from same chapter, electricity. When is the potential difference between 2 points is said to be 1 volt? Okay, so I repeat every time, like when I am when we are taking care of electricity chapter, I repeat to the students for every several times. If this kind of question you can expect, this kind of question you can expect. 1 second, 1 second. What happened? Is it okay now? Fine. Yeah, we should become blurred, right? Now, what is the condition? Still, the issue is there. Like, okay, let me check. Is it okay right now? No. Is the issue was there in the beginning? Is this issue was there in the beginning? One second. One second. One second. Yeah, now it is okay, right? Okay, okay. What about right now? Now is it okay? Okay, okay. Okay, sorry for the trouble. Okay, fine. Okay, so here when potential difference between the 2 points said to be 1 volt, when it is said to be 1 volt, I think this issue was there for a long before, right? So if okay, so I think the previous questions have this kind of issue. So it's not seems to be like okay. So those who missed the answer for this question, please recap it. Okay. So like yeah. Okay. So let's move to our question. Okay, fine. So now it is readable, right? Okay. Now when the potential difference between the 2 points said to be 1 volt. Okay. What is the definition for potential difference? V is equal to work by charge. When W is equal to 1, Q equal to 1. W 1 joule and Q 1 coulomb. Okay, when 1 joule of work is done to move 1 coulomb charge from one point to another, the potential difference between the 2 points is 1 volt. So after substituting this, W equal to 1 joule divided by Q equal to 1 coulomb, you will be getting 1 joule per coulomb. 1 joule per coulomb is equal to 1 volt. Okay, so when 1 joule of work is done to bring a unit positive charge from one point to another, that is what is called 1 volt. Okay, so 1 volt is that potential difference existing between 2 points when 1 joule of work is done to move the charge from one point to another. That's it. Okay, clear? Clear? Yes. Okay, a copper wire has a diameter of 0.2 millimeter and resistivity of 1.6 into 10 to the minus 8 ohm meter. What will be the length of this wire to make its resistance 14 ohm? How much does the resistance change if the diameter of the wire is doubled? Okay, it's a numerical again. It's a numerical again. Okay, we can go with that question. Okay, listen. Copper wire has a diameter. So D is equal to 0.2 millimeter means 10 to the power minus 3 meter is equal to 2 into 10 to the power minus 1 meter. Okay, 2 into 10 to the power minus 1 meter. Resistivity rho is given. Rho is equal to 1.6 into 10 to the power minus 8 ohm meter. What will be the length? Length we need to find to make a resistance of 14. So R is also given 14 ohm. So it's just a matter of substituting these values in the equation. We have R equal to rho L by A. So L is equal to R A by rho. It is substituted. So you can substitute, but A you need to calculate. A is equal to pi R square. Pi R square here diameter which is given. So pi into D by 2 whole square which is D square by 4. So is equal to 22 by 7 into pi means sorry D means 2 into 10 raised to minus 4 whole square divided by 4. So you can substitute here. What is R? 14 it is. Okay, R is 14 over here. Okay, R is 14. A is equal to what you have got for A? A is equal to 22 by 7 into 2 into 10 raised to minus 4 by minus 4 whole square divided by 4 it is. So rho is 1.6 into 10 to the power minus 8 into 4 it is. Okay, so it's just a matter of calculating this one. Okay, substitute the values, calculate this one. What will be the value that you are getting? So 22 by 7 into 14 into 2 into 10 raised to minus 4 whole square divided by 1.6 into 10 raised to minus 8 into 4. Okay, so it become 22 by 7 into 14 into 2 square is 4, 10 raised to minus 4 square is 10 raised to minus 8 divided by 1.6 into 10 raised to minus 8 into 4. Okay, so 4 cancelled like that. After, like, you can calculate it, like, as we need to conclude right now, I'll be rightly going to the answer. The answer is going to be 27.5 meter. After substituting, you will be getting 27.5 meter. It's just a matter of substitution. Just a matter of substitution. You'll be getting 27.5 meter. That's it. Okay. 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 One more question is there. Okay. What was the question? A copper. Okay. Let us keep this question over here. Then I can write on the top. Okay. A copper wire has a diameter. Okay. No, that is done. How much does the resistance change if the diameter of the wire is doubled? Diameter doubled. Okay. So we know that R is equal to rho L by A. So R dash is equal to rho L by A dash. Only length is not more changing. Okay, length is no more changing. Only the quantity which is changing is diameter. So diameter changed. So A dash will be changed. Okay, so we need to find the change over the resistance, right? So we can find the ratio. R dash by R is equal to rho L by A dash divided by rho L by A. So it become rho L cancelled, A by A dash, A by A dash it is. So what you are getting is R dash by R is equal to A by A dash. R dash by, as they are inversely proportional, the resistance is inversely proportional to area of cross section. So ratio of that one will be inversed. R dash by R is equal to R dash by R is equal to A by A dash. Okay, so diameter is doubled. What happened to, if diameter change it to 2D, what happened to its area of cross section? If resistance doubled or diameter doubled, as you're taking in the area means pi r square. So diameter change, it become its square 2 times. So A dash will be 4A. A dash will be 4A because square time is changed. Square time is changed. So 2 square is 4. So 4 times is changed. So we can take it like A dash is equal to 4A. So R dash by R is equal to A by 4A. R dash by R is equal to R dash by R is equal to A by 4A. So what you will get means A cancelled. So R dash by R, what is the value of R? What is the value of R? 14 is equal to 1 by 4. So R dash is equal to 14 by 4. 14 by 2 is 7. 7 by 2 is 3.5. So 14 by 4 is 3.5 it is. So R dash will be getting 3.5 ohm. R dash will be getting 3.5 ohm. So what, how much does the resistance change if the diameter of the wire is doubled? If the diameter of the wire doubled, resistance change, resistance become 3.5. So what is the change in resistance? That's the question. Change in resistance, we need to find the change in resistance. So change in resistance, change in resistance is equal to R minus R dash, that is 14 minus 3.5 is equal to 10.5 ohm. That is the change in resistance. So change in resistance is 10.5 ohm. Okay, so old resistance minus new resistance, that is the change in resistance. So 10.5 ohm will be the change in resistance. Okay, fine, fine. Okay, clear? Is it clear? So last question from this chapter. So not from this chapter, from the question paper in physics. Okay, a highly polished surfaces, case study type of question, like, okay, such as mirror reflect most of the light falling on it. In our daily life, we use two types of mirrors, plain mirror and spherical mirror. The reflecting surface of a spherical mirror may be curved inward or outward. So like in a concave mirror, reflection take place from the inner surface, while a convex mirror, that we already know, like mirrors reflection take place from the outer surface. Define the principal axis of a concave mirror. What is principal axis? The line passing through pole and center of curvature. Line passing through pole and center of curvature is called principal axis. That's exact question, please. Okay, so a ray of light incident on a concave mirror parallel to its principal axis. If it's okay, concave mirror, on a concave mirror, one second, on a concave mirror it is principal axis parallel to it, incident rays are falling on it. Okay, then what is happening? Okay, from a point at a distance of 10 centimeter from the pole of the mirror. Okay, so either this parallel rays after reflection from the mirror passes through the principal axis from a point at a distance 10 centimeter. You know that this will be reflected like this, and this point is called parallel to the principal axis. Incident rays are coming, they will be reflected through focus, right? Reflected through focus. So that distance is given as 10 centimeter. That distance is given as 10 centimeter. So its focal length is 10 centimeter. That they are indirectly given. Okay. Now what is asked in the question? So from the mirror, find the radius of curvature. What's the relation between radius of curvature and focal length? You know that R is equal to 2F. R is equal to 2F. So radius of curvature is going to be 2 into 10 is 20 centimeter. As it is concave mirror, we can take it like concave radius of curvature is negative 20 centimeter. Concave radius of curvature is negative, you know. So we can take it like radius of curvature is negative 20 centimeter. That's it. It seems to be a like very lengthy question, but answer is negative 20 centimeter. That's it. Okay. Okay. Find it easy. Okay. So one more question is there. Not one more, like two more. Okay, so for question C, there is or question, either you can attempt this one or this one. Okay, so let us see, it's a numerical, I think. An object is placed at a distance of 10 centimeter from the pole of a convex mirror of focal length 50 centimeter. Find the position of the image. Use the mirror equation. What is mirror equation? 1 by F is equal to 1 by V plus 1 by U. 1 by F is equal to 1 by V plus 1 by U. Okay, let us find it this way. Okay, so here F is equal to what type of mirror it is? Convex mirror. F is positive. Convex, focal length is positive. So 15 centimeter. Then object is placed. U is equal to object distance is always negative. Object distance is always negative, as you might know. Okay, 10 centimeter. You need to find the position of the image. So 1 by V, rearrange it. 1 by V is equal to 1 by F minus 1 by U, which is equal to 1 by F, 1 by 15 minus 10. So which is equal to 1 by V is equal to 1 by 15 plus 1 by 10 is equal to LCM is 30, right? 15 and 10. LCM is 30. So 2 by 30 plus 3 by 30 is equal to 5 by 30. It is 1 by V is 5 by 30. So 1 by V is equal to 5 by 30 is 1 by 6. So you'll be getting V equal to 6 centimeter. Very easy. V is equal to 6 centimeter. So calculation part we can see do. So it's all direct question which is asked for mirror equation, direct question, very easy. Okay, so a mirror forms a virtual erect and diminished image of an object. Identify the type of this mirror. Okay, so plain mirror can give only same sized image. So there is two mirror, converging mirror and diverging mirror, convex and concave, which can give diminished image. Okay, so out of which a mirror forms virtual erect and diminished image of an object. So which is giving virtual image of like virtual diminished image. Virtual diminished image is given by convex mirror. Concave mirror is giving diminished image which is real. Okay, so the convex mirror which is giving virtual image which is diminished. Okay, and it is erect too. It is erect too. So convex mirror is the mirror which is giving convex mirror, or diverging mirror is the mirror which is giving that kind of like a diminished virtual image. Identify the type of the mirror. This is convex mirror, or you can like convex mirror is diverging mirror. Okay, then draw the ray diagram to show the image formation of on this case. That is very easy. Okay, what's the formation? Ray diagram of image formation. You have to draw the convex mirror. Then we can mark the principal axis. This is the principal axis. Okay, you know that focus is lying over here. Focus. Okay, now center of curvature also you can mark. Okay, so if focal length you have taken 5 centimeter, you have to mark at 10 centimeter as center of curvature. Okay, now object we can place it over here. Okay, first incident ray you can take like coming parallel to principal axis. Okay, so parallel to principal axis, how will be reflected? It will be reflected from focus up here to, as it is converse, it is virtually it will be coming from focus. Virtually it will be coming from focus. So this is the reflected ray. So second incident ray, how can you take, like this is passing through center of curvature. Okay, let us take it like this, passing to center of curvature, but you know that this side you need to mark like it is virtually you need to mark. Okay, it will be follow the same path as it is directed towards center of curvature. It will be follows the same path. So as image form, if you are extending this rays, it will not be meet at this point. This side it won't meet. This side they won't meet. They are diverging here. So they will be meeting virtually at this point. At this point they are virtually meeting. So there will be the image formed. So virtual image will form over there. So this is a kind of ray diagram you should draw with the convex mirror. Draw a ray diagram related to for a convex mirror. That's it. So that you will be getting the answer. That's it. Easy question. So apart from MCQ, you have troubled. MCQ have troubled you, but apart from that, all the 2 marker, 3 marker, 4 marker, and 5 marker is pretty easy. Okay, so this all about uh, our last year 2024 physics questions. I have finished all the question including our question. Okay, so if you want to comment like whether sample paper for this year or last year or the other sets which is alternate regions in India which we want to discuss in next class, please do comment over here so we can see next class accordingly. Okay, so please I'll be noticing your cover, even though if you are seeing the live today or like tomorrow, whatever it is, you can give a comment like which chapter, which question paper you want to discuss over here. We can do it. Okay, no worries. Well, let us recap then. Bye bye. Sign off.